say, how would you start this? Chris? Right, 3 goes into 3 one time. We'd do 3 times 1 is 3. We'd line it up. We would do what operation? Subtraction. You'd get 0. You'd bring down your 5. Perfect. And then you'd repeat. 3 goes into 5 how many times? Once. 3 times 1 is 3. Do your subtraction. You get 2. Bring down your 7. 3 goes into 27. 9 times. 9 times 3 is 27. Subtract, bring down your 0. 3 goes into 0 how many times? 0. 3 times 0 is 0. Do your subtraction. You're done. And because this is your 0, you have no remainder, correct? And if you have no remainder, what does that mean about how 3 goes into 3,570? Goes in evenly, which means it is a factor of it, right? 3 is a factor of 3,570. Now let's do 3 going into 3,571. So 3 goes into 3, we'll just fly through this. Similarly, you guys can just watch this if you want. 3 times 9 is 27. Bring down your 1. Why am I doing this when I had 2 numbers? Whatever. So 3 goes into 1 0 times. And so we have a remainder on this one of 1. Yes? So if you have a remainder, that means 3 does not go into this evenly. It goes in this many times, but with 1 left over. So when you first started doing this, do you remember when you would do like 1190 and then you'd put like R1, which is so not mathematically correct, but do you remember doing that? No? What did you do with the remainder? You did? Some of you remember, some of you didn't. After a while, you then started saying if you knew the remainder was 1, you would put 1 over the 3. It would really be 1,190 and 1/3. Yes? Okay, so we're going to piggyback off of a lot of these ideas. If there's no remainder, then it's a factor. It goes in evenly. If there is a remainder, then that remainder gets written over the divisor. That kind of stuff. So we'll piggyback on what we already know when we do long division with polynomials. Okay? So here's how this is going to work. Exercise 3. We're going to write it similarly. And our divisor is x plus 6. We're trying to see if x plus 6 goes in evenly. We are trying to see if x plus 6 is a factor. So when you're going through long division, you take this x and just the leading term, and you ask yourself, x times what would give me 2x squared? 2x. So put that up there. And then you multiply 2x by the entire x plus 6 and line it up. So 2x times x is 2x squared, and 2x times 6 is positive 12x. And just like we did before, we're going to do subtraction in between each of these terms. Don't put your subtraction out in front. You'll forget to distribute it. Put it in between each and every term. So 2x squared minus 2x squared is gone. 15x minus 12x is 3x, and we're going to bring down our plus 18. And we repeat. So go back to your leading term x. X times what would give me 3x? 3. Positive 3. So put that positive 3 up top. Multiply the 3 by the x plus 6, so you get 3x plus 18. Do your subtraction. You get 0. There's nothing else to bring down. We're done. We had a remainder of 0, so we know that x plus 6 is a factor. Okay? That makes sense? Not only that, but if you go back to the numerical example, what we know is that whatever's on the outside, the divisor, whatever your answer is, the quotient, 3 times that gives us that. So those are factors of 3570. 3 times 1,190. Similarly, we've just factored this. X plus 6 times 2x plus 3 gives us that. So x plus 6 times 2x plus 3 is the factored version of that original 2x squared plus 15x plus 18. That is something you would have been able to factor the old traditional way. But there's lots of things that, like, you would have just probably split the middle term or guessed and checked to factor that. But I started with one that worked out nicely just so you could see. If you did guess and check, you probably would have done 2x and x. And then you would have played around with the 18 so that the outer and the inner would work, and you would have gotten 6 and 3. You would have been able to factor it just fine using your traditional methods, but there's a lot of things that the traditional methods don't work for, and so the last resort for factoring is long division. Okay? The issue with long division is you have to know what to divide out. You have to be told what to kind of start with. So we'll build on all this. Let's jump to this one. Your 3x plus 4 goes on the outside. And we start. 3x times what will give me 6x cubed? 2x squared. Good. So multiply that 2x squared by both of those terms. Line it up. So 6x cubed plus 8x squared. Do each of your subtractions. And 17 minus 8 is 9x squared. Bring down your 27. What number goes up here next, do you think, Lucas B? 3x times 3 would be 9x. I need it to be 9x squared. 3x, very good. Positive 3x. So I need 9x squared plus 12x. Do my subtraction. And 27 minus 12 gives us 15x. Bring down your 20. And then 3x times what, Jack B? Will give me 15x. Plus 5. So we have 15x plus 20. Do your subtraction. 0. So here is something that would not have been factorable by hand. Grouping wasn't going to work on this. But by being told to divide out 3x plus 4, what I just realized is that this is factorable into 3x plus 4 times 2x squared plus 3x plus 5. Okie doke. Couple things on each of these. The numerator is not in the right order. You have to keep things in the right order. So when I rewrite this, my x to the 4th is going to come first, then my minus 5x cubed, then my plus x squared, then my minus 5x. Not all over. And I'm dividing it by 5 plus x, which also isn't in the right order. I need to do x plus 5. Okie doke. So make sure you reorder it. And this polynomial is also missing the constant at the end, so put plus 0 to fill that in. We're not gonna do that one out. If you jump to exercise 6, what's tricky about this one is that we skipped some terms. So when you do this, you have your x to the 4th. Your next term should be an x cubed plus 0x cubed minus 13x squared plus 0x plus 36. And your divisor is also missing an x term. So x squared plus 0x minus 4. You want to fill in the gaps so that everything stays lined up. So let's start this one. X squared times what gives us x to the 4th? X squared. So I'm going to get x to the 4th plus 0x cubed minus 4x squared. when I do my subtraction, that's going to cancel, that's going to cancel. Careful of your double negative here. Negative 13 minus a negative 4. Nope, it's negative 13 plus 4, negative 9x squared. And on this one, we're going to bring down our next two terms because we want it to be a trinomial because our original is a trinomial. Follow? So we start again. X squared times what is negative 9x squared? Negative 9. So we're going to do negative 9x squared minus 0x plus 36. Do your subtraction. Everything's a 0. So that factored into x squared minus 9 times x squared minus 4. Okay, last thing to talk about. What is it like? Just watch this one. Let me fly through this one. Just watch. X times x cubed. Don't write this down. Don't even bother. Do your subtraction. Negative 5 minus 5 is actually negative 10. Bring down your x squared. Repeat. So this is negative 10x squared. Do your subtraction. 1 minus negative 50 is 51. Oh, this is ugly. Plus 51x will make this 51x squared plus 255. Do your subtraction. Negative 5 minus 255 is negative 260x. Bring down your 0. This will be negative 260. Negative 260x minus 1,300, I think. So here's my point. We have a remainder on this one. If you have a remainder, it gets added on to the polynomial as whatever that remainder is over the divisor x plus 5. Just like we did in this example, we had a remainder of 1 and we put it over the divisor 3. Any questions? Only ball game. No revision. What? I don't blame you because you have a calculator, so you probably haven't done it in at least 5 years. Have a great Thanksgiving. Anybody leaving the state?